Hello friends, myself Shubhada Kulkarni, and today we are going to continue our discussion about the lesson electric spark. We have seen the current, we have seen the potential difference, and now we are going to see the third parameter. For that we are going to learn Ohm's law. The German scientists have stated the relationship between current flowing through a circuit and voltage applied to it. It states that whenever we apply some voltage or some potential difference across the circuit, the current flowing through it is directly proportional to the voltage applied across it. For this, we have done this arrangement. We have 4 number of cells, or this is the batteries where voltages or potential differences are connected in series. So that we are going to add on the applied voltage across the circuit, and according to that we are going to observe the current through it. Here the voltage drop across the resistance or the load or the application is observed by connecting the voltmeter, and ampere meter or ammeter gives us the current flowing through the circuit. Thus we are going to write down in this experiment the different readings of voltage applied to the circuit and according to the change in the current, and then we are going to find out this factor resistance. Resistance is nothing but the actual mathematically it is the ratio of V upon I, voltage upon current, and we can explain this factor like whenever the free electrons are moving in a conductor material, they are nullifying the effect of each other's speed. Because they are randomly moving, they are nullifying the effects of each other's speed. So, until we apply the voltage across the circuit, we are not able to see the flow of current. When the potential is applied across the circuit, we are observing the current. And at that time, we have seen the concept that all the negative charge particles are flowing in a unique direction according to the battery supply connected. So, this depends upon the material, this resistance depends upon the material we are using as a conductor and also for the appliance. The Ohm's law states that the current is proportional to voltage, but for that the physical conditions are going to be stable. For stable physical conditions, the Ohm's law is true. What are these physical conditions? The physical conditions means the material used for the conductor, the cross-sectional area of the conductor, or the area through which the current is flowing, and the length of the conductor. These are the parameters used to decide the resistance, and afterwards we are going to see the property resistivity of the material. For that also we are going to see how these factors are very much important. We, according to our observations, we plot the graph, and this graph will come like this. It will show us V upon I is equals to R. We will calculate for different values of V, the value of R. Now we will see the example. Find the resistance of a conductor if 0.24 ampere current is passing through it and a potential difference of 24 volt is applied across it. Given data is current 0.24 ampere, voltage is 24 volts. So, according to Ohm's law, 24 volts upon 0.24 amperes. This is nothing but 24 which is 100 ohms. Thus we have found out the resistance of this circuit. The internal resistance of this battery is there, which is very small, which is shown by small r. We will continue the next concept of resistivity. Actually, this resistivity is also dependent on the length, area of cross sectional of the material. The resistance of the conductor is directly proportional to length. If we increase the length of the conductor, then the electrons moving through the conductor, they are flowing through the conductor, and they get obstacles in between them of different moving charged particles like the same electrons. Sometimes sometimes they fill the valency of the material, of the atom which is present, and thus they stop there. The movement of the electrons stops there. Sometimes the electrons which get the sufficient potential difference from the battery, it becomes successful to reach to the next from negative end to the positive end. It becomes successful to complete its travel through the circuit, and then our current we are going to able to see. Thus, resistance depends upon the length. If length is increased, resistance of that conductor is increased. If area of cross sectional increases, then the resistance decreases. How? See, we will see an example of a pipe which is carrying a water. We will take an example of water again. If the diameter of pipe is increased, more water can flow through the pipe. Similarly, here more number of electrons can flow through the same pipe if its diameter is more than of the same material but having cross sectional area different. See, if the small conductor is used, its cross sectional area is A by 2, length is constant, then obviously small passage is used for passing the current. Thus, ultimately, resistance is directly proportional to length and inversely proportional to area of cross section of the conductor. This mathematically we can represent as R equals to rho L upon A, where rho is constant and rho is known as specific resistance or resistivity of the conductor. We will take the example. If the length of the wire is 50 centimeter and radius is 0.5 millimeter, find the resistivity of wire if its resistance is 30 ohms. The given data is length equal to 50 centimeter, R is equals to radius of this conductor is equals to 0.5 into 0.5 millimeter means 0.5 into 10 raised to minus 3 meter, which also can be written as 5 into 10 raised to minus 4 meter. Resistance is 30 ohms. Now we will, according to our formula, the resistance is rho L upon A, from which we can derive rho equals to RA upon L. Now here area is nothing but the area of cross section of the conductor, which is a cylinder, which is a circular actually. As rho is constant, we are able to see the final answer as 47.1 into 10 raised to minus 6. The value of rho is 47.1 into 10 raised to minus 6. This is all related to the physical parameters, resistance and resistivity of a conductor. Thank you.
So guys, stay innovative, stay hungry, subscribe the channel, press the bell icon. I will get back to you very soon with new stuffs. Till then, bye bye.